Can you guys hear me okay tonight? Hey AP Psych students, I'm Megan with Fiveable. I'm here tonight with you to go over some research methods. Can you guys just let me know if you can hear me okay? I was having a little trouble getting the video feed started. So if someone could just let me know in the chat, that would be great. Anyone? Perfect. Thanks, Tamara. Thank you. Megan with Fiveable. I am here tonight to help you prepare for your upcoming AP test in May, but also to kind of get you ready for your kind of weekly or monthly tests that you take in class. And so today we're going to talk about research methods, specifically descriptive methods versus experimentation. Before we jump in, though, there's a couple of things I want to point out. If you're new to Crowdcast, which is the platform here that we use, you can ask me questions anytime today throughout the session. If you just click on the Ask a Question button there at the bottom of your screen, you can type it in and I'll get to the question as soon as I notice it and there's like a break in the session. Also, I have a poll set up. There's 5 practice questions we're going to do later. You can see also on the bottom of your screen where it says polls. Don't click on anything yet because you don't know the question, but once I post the questions, you'll be able to respond via the poll what your answer is going to be, and we can kind of talk about how to respond to multiple choice questions and things like that. So jumping in here, just a couple of other reminders. We have some upcoming review sessions. Next Tuesday, we'll go over statistics and basically just kind of the stats you need to know for AP Psych, kind of sum it up and kind of focus on just the main ideas. And then we jump into the bio unit, which is a really heavy hitter. And that's a unit that a lot of kids struggle with. So if you want to stick with us and follow us, those would be some good sessions to join. So I'll be here every Tuesday night at this time, and hopefully you guys can make it too. So on to the review. Research methods is the unit then that we're reviewing tonight. And this unit, the big idea here is that psychology is a science. It's one of the big things that College Board tries to stress and AP tries to stress, is that even though social studies even though psychology, is in the social studies department, a lot of the times it is a science, and there's methodology and research to back up a lot of the claims. And so this whole unit is about how to be kind of a good scientist in psychology. This is a pretty big unit. It makes up about 8 to 10% of the AP exam. So knowing these things is going to be really helpful for you, especially if you're like really good at stats and things like that. This is going to be a good unit to help you out on the test. Let me just look here. Someone asked, if I leave, will I be able to look at the questions? You won't be able to see them live, but the videos do pre-record, so you can come back later and watch the videos if you subscribe. So if you do have to leave for some reason tonight and aren't able to see the review questions, they will be on the live review later. You just won't be able to answer actively with us. Good question. And then the last thing, the 2 main parts of this unit are kind of how we're going to focus on the review. Today, we're looking at specific methodology in psychology, and then next time we'll look at the ways we measure the outcomes of our research, which would be the stats part of the unit. So first, we have to understand the difference between the 2 main types of research methods that we're going to talk about in psychology, and those are descriptive versus experimental. And descriptive methods basically just describe or measure humans as they already are. I'm not going in and manipulating or changing or doing anything to someone. I'm just kind of investigating them as is. The big thing here, and this is how they're probably going to trick you on a question, maybe on the AP test, is that if we're using descriptive methods, we cannot conclude cause and effect. We might be able to say, oh, it seems like there's a relationship here, or I bet these 2 things are related, but without conducting an actual experiment, I cannot for certain conclude cause and effect. So if a question asks you about doing a naturalistic observation and then concluding that it's true that, let's see, maybe that apes use language. Without doing an actual experiment to verify that, we can't make that conclusion. We can assume that maybe that's true, but without an experiment to actually come to that conclusion, it would be inaccurate to say that. So that's kind of the big thing there where they might get you, is the cause and effect. And then there's four main ways that we look at descriptive methods. There's a case study, naturalistic observation, survey, and correlational study. And we're going to look at all of those a little more in-depthly as we go. So I'm going to just kind of jump over those. And then besides descriptive methods, we use experiments in psychology. And an experiment is when we actually are manipulating a variable in either a human or an animal and then measuring the results of that variable. And so just like with descriptive methods where we can't conclude cause and effect, experiments are how we conclude cause and effect. So that's a big key there. And so we want to always, if we can, do an experiment, but with some of the things that we study in psychology, it wouldn't be ethical or wise to do an experiment. And so we can't always rely on that. We just have to make the observations that we have available to us. All right, so the first then method we're going to look at is the case study. How many of you can just let me know in the chat, have talked about Phineas Gage? He's kind of one of the most common case studies that AP Psychology looks at. But in a case study, what I'm doing is studying one person really, really in-depthly. I'm going to study all aspects of their lives, and I might follow them even for years and check in with them monthly and get all kinds of data about this one person. And we're going to make general observations then about the population as a whole based on this one person's information. And so the good thing about a case study is that it is super detailed because I'm following this person and gathering all this data and all of this information. But the bad thing is that we can't replicate it or often make big generalizations because in a case study, we're usually studying someone who's super unique. And so, for example, Phineas Gage is here, and you can see the pictures of him. He actually suffered a railroad spike through his face and into his brain. And so we can't repeat that experiment, right? I can't have people sign up and volunteer to have a railroad spike driven through their head to see what the results are. So instead of doing that, we just study Phineas really in-depthly and make observations about, the part of his brain, part of the frontal lobe was damaged, and we saw changes in certain personalities and behaviors. And so we can make generalizations that, based on this, I think that part of the brain might have to do with personality, or it might have to do with intelligence, but without being able to replicate it, I can't for sure make those judgments. Two other really pretty famous case studies would be patient HM, and they might ask about this on the AP test, but patient HM was someone who had their hippocampus removed, and so that's a part of your brain that deals with memory. And when the hippocampus was removed, he stopped being able to form new memories, and short term. And so if he lived the rest of his life, he would introduce himself to you over and over again. He'd forget where he set his keys down. He wouldn't remember what he had for breakfast or even that he ate breakfast that day. And so that case study let us learn a lot more about human memory and how the hippocampus deals with memory and the formation of memories. And then the last one, I'm going to put a plug in. This is probably my favorite case study, David Reimer. And there's a documentary that I'm going to link after this video that you could watch if you're interested, from BBC. But basically, David Reimer is one of a set of twins. They were born, I want to say, in maybe the 60s or 70s. And what ended up happening was they went in, there was two boys. They went in for a routine circumcision, and there was an accident, and part of David's penis was actually cut off. And so he was a baby, right? So he didn't really know anything except that it probably was painful. And so his parents had to make a decision about what to do with David. And so they decided to actually fully remove the penis and raise him as a girl. And so this, if you were here last time, gets into our kind of nature-nurture debate about are we born kind of with the traits we already have, or does it have to do with how we're raised? And so this study led us to looking at, is gender something that's innate? Are we born kind of knowing that we feel like a girl or feel like a boy? Or is gender something that you can actually teach someone? And so David is born, as a boy physically and everything, but his parents raised him as a girl. And so the documentary gets into kind of the ethics of this, which today would be super unethical and we wouldn't be allowed to do. And then kind of the results. And I'll just give you a little spoiler alert. David did not ever really feel like a girl and ended up having a lot of problems later in life because of how his parents tried to raise him as a girl. He never felt quite right, and there was a lot of consequences to those actions. So if that sounds interesting to you, there's a really good documentary, and there's a lot of psychology in it, and so I would recommend watching that. So that kind of sums up case studies. The next main method of descriptive methods we could use is called naturalistic observation. And these are all under the descriptive category. So we're not making cause and effect conclusions. We're just describing humans or animals as they are. So the naturalistic observation records behavior in a natural environment or a native environment without manipulation or control. And you can see the picture here. That's Jane Goodall. She's really famous for studying apes. And what she did was naturalistic observation. You can see her there. She's just sitting beneath that tree, not interfering with what's going on, and just making general observations about behavior of animals. The pros of this are that we can study animals in a more native environment than like putting someone in a lab and trying to study them. Because if we put you in a lab, that's already not a natural environment. And so it might alter your behavior, your actions, or your thinking. The cons of this is that just the fact that she's there or that a person's there could alter your behavior and it becomes less natural. And so we can never be certain if the addition of an observer writing down information actually keeps your behavior genuine or natural. Another problem is that there could be observer bias. The person that's sitting there recording might have preconceived notions about what they're studying. And so it's their interpretation of what's happening. It's not free from bias. And there's also no control in setting this up. The two kind of big famous examples then, like I mentioned, would be Jane Goodall and then Charles Darwin studying like natural selection, how he did. And this is something you could do. I have my students go to the lunchroom and actually just do a naturalistic observation. They like talk about teenage behavior or lunchroom habits of teenagers, and then they just record information about what they see going on around them, and then they make conclusions about teenagers at the time. And so this is something you could easily do as well. We'll talk, though, a little bit more about the ethics of doing a study on people without their permission or their knowledge a little bit later. I think that one's pretty straightforward, but if you have any questions, kind of let me know. Otherwise, I'm going to move on to the next one. The next method, and this is one we probably all have a little bit of experience with, is the survey method. And a survey is just an attempt to capture a population's attitude and experiences. And the great thing about a survey is, especially with like modern technology, I can just shoot out an email to thousands of people at one time and get data back. So it's really easy to reach a lot of people, and so we can get a bigger, better picture of whatever it is we're studying. I can also create multiple surveys really easily. If I'm like seeing weird results, maybe I didn't word questions exactly how I wanted to, or maybe I didn't send it to like enough people, I can always come up with a new survey and send it out. It's pretty easy. So this is probably the easiest research method to reach the biggest audience. The cons of this would be I can't be certain that people are telling the truth, especially if I'm like doing a survey about something like, have you ever stolen something from the grocery store? Something like that, people might not be super honest about, and so the data could get skewed just because they're ashamed or embarrassed and don't want to answer the question exactly correctly. The other problem would be wording effects, and then there's not a ton of us here, but does anyone want to take a shot at what wording effects are or how they could impact a study? I'll give you guys like 10-20 seconds if someone wants to take a shot at it. Otherwise, I'll jump in with the answer. But does anyone have an idea what a wording effect is? Yeah, Anna, that's great. So basically, I have to be careful when I'm writing questions so that I'm not leading someone to the answer that I want. And that could be in a variety of ways. It could be the order of the questions. It could be how the questions are written. It could even be the language that I use. Like if I'm writing about your habits towards certain foods and I use the phrase, 90% fat-free versus 10% fat, those get different responses just because 10% fat sounds icky and gross and people don't like that, versus 90% fat-free sounds, oh, that's pretty good. That seems good. And so just how you word the questions, the language that you use, the order in which they're presented, all of that can have an impact. And so you want to be really careful about that when you're completing a survey so that you don't bias the results. And then when we do a survey, we're generally trying to make a judgment or an inference about our population. And so I'll just use my school as an example. Let's say I want to study how long students study every night at Middleton High School. So my population then is all students at Middleton High School. That's who I'm studying. But let's say it's not realistic for me to actually get all of them to take this survey. So I have to take a sample of that population. And so a sample, like you can see on the infographic there, is just a few people, or it could be a lot, but people pulled from the population that actually participate in the survey, and then I can infer my data based on those people. The key here, though, that you have to also be really careful about is that it's random. You can't like pick and just choose people. It has to be really random. And so you would want to like put everybody's name in a random name generator and pick 50 names out, or put everybody's name in a hat and pick names out. You want to make sure that what you're doing is truly random, because if it's random, then it's representative. And what representative means then is that I can extrapolate that information and make inferences about the population, because you wouldn't want to have 50 girls in your study and no boys, or you wouldn't want 50 freshmen in your sample and no seniors, because that's going to skew the data in a different way. So if we're truly picking randomly, we should have some seniors and some juniors and some sophomores and some freshmen and some boys and some girls and different backgrounds and all that stuff. And so that's why we really want to make sure we're random, so that we can actually say that our data is useful and representative of what we're talking about. All right. Then the last sort of descriptive method would be a correlational study. And this is just taking two variables and trying to see if they're related or not. We plot them on a graph and then look at how the data is spread out. And so on the top there, we have like a positive correlation, which is where we can kind of see the line going upward and to the right. In the middle, we have a negative correlation because it's going down. And then if the dots are all just spread out on the graph, there's really no correlation there. And so an example of something that we could plot to see if it has a positive correlation would be height and shoe size. And we typically could infer that the taller you are, the bigger shoes that you wear. And so that would look like something towards that positive correlation graph there on the left. As one goes up, the other goes up. And we would see that plotted together. While I'm talking, can anyone think of something that would have a negative correlation? What that means is one of our data points increases, the other data point would decrease. So think about that for a second while I'm talking and see if you can come up with something that would have that sort of a relationship. And so how we measure in a correlational study is we use something called a correlational coefficient. And that's a number that you have to understand and know where it comes from. And so there's a couple parts to a correlational coefficient. The first is the plus or the minus sign. And so that indicates the direction of the relationship. If it's got a plus sign, it's a positive relationship. As one number goes up, the other number goes up. If it's got a negative sign in front of it, that means it has a negative or an inverse correlation. So as one number goes up, the other number goes down. And so my example for a negative correlation would be as the temperature increases, hot chocolate sales would decrease most likely. So as one number goes up, the other one is decreasing. That's a negative correlation or an inverse relationship. And then the actual number in the correlation coefficient tells us how strong that relationship is. And a correlation coefficient can only go from -1 to 1. So if you're getting a number like 7, that's not a correlation coefficient because that just doesn't exist. the number has to be from -1 to 1. If we had a plus 1.00, that would look exactly like that blue line in that first image. It would just be an exact perfect straight line. That means that, you know, they go up together at the same time. Yes, it is necessary to know about correlations for the AP exam. Someone asked a question there in the chat. Typically, sometimes they'll actually show you a graph like what I have here and ask you which number best represents it. Sometimes they'll show you a number and ask you to describe like the relationship that exists based on the number, but it is something that definitely comes up probably almost every year on the AP test, either in multiple choice format or in the actual written part. So I would definitely make sure you don't need to know specifically how to calculate the number. You just need to know what it represents. So -1 then would be the same as +1, except it's the downward slope line. And so as we get closer to 0, the more scattered out our data gets. So if we look at the one that says no correlation there in the upper right, that one's going to be like a 0 because there's no line forming there at all. The data points are all spread out. And so if we had, I actually just kind of wrote out here what it might look like. R is the variable that represents correlational coefficient. So if you ever see like R equals, you should know that that's a correlational study that they're referencing. R equals plus 0.98. That would probably be that first graph there for positive correlation. It doesn't form an exact perfect straight line. There's a little spread in the data points, but it's pretty close. And then the middle one where it says negative correlation would probably be like an R equals -0.96. Again, not a straight line, but the data points are pretty close to a straight line. And then the last one, R equals 0.12. There's just a lot of spread. We really can't make a representation by looking at the graphs. Someone in the questions put, the amount of video games you play is what makes your grades go lower would be a negative correlation. That is correct. The more time I spend on video games, as that number goes up, my grades go down. And so those would be a negative or an inverse correlation. One went up, one went down. That's a really good example. Thanks, Amelia. Good. So that's correlations. I would really say the big thing is practice looking at a graph and understanding like the data points and what that tells us, and then making sure you know that the R equals and what that number means. And there's a lot of practice questions out there where you can just look at a graph or a chart and then answer that question based on the chart. And so you can get a better feel for it. Okay, we're going to move on then from correlation. Oh, sorry, one more slide. The reason why in a correlational study we have to be careful because we still can't determine cause and effect is because it can predict the relationship, right? I'm looking at how many hours of video games you play a day versus your grades, and I can predict what that relationship is going to be. But again, I can't necessarily predict why. And so a good example of that is here, why we can't use a correlational study to necessarily predict cause and effect. Because if someone has low self-esteem and depression, it could be that your low self-esteem, the way you kind of think about yourself and the way you interpret yourself, causes you to feel depressed and have depression. Or the fact that you already have depression could impact your self-esteem, and it might make you feel bad about yourself and have lower self-esteem in general. A correlational study doesn't tell me which causes which. It just tells me that there's a relationship there that exists. Or there could even be a third factor here. There could be a distressing life event or a biological circumstance that causes both low self-esteem and depression. And so without actually doing an experiment and further studying that, I can't make a conclusion about that with my correlation. I can just say, yep, I know a relationship appears to exist there, but I don't necessarily know why and in what direction that relationship goes. So please be careful, because I think with correlation, sometimes it seems like we're making a conclusion that this causes that. But in reality, we're just saying there's a relationship here and we need to investigate more about that relationship. And just for a little fun, I like to always look at this website. There's more of these, but they're called Spurious Correlations. And basically, this is just a warning to always kind of be wary about the data that you're looking at. Because this guy made this website, and basically he takes data that seems to coincide. And so the red line on the first one here is total revenue generated by arcades in the United States. And then the black line is computer science doctorates awarded. And it appears that those two numbers are correlated. They move pretty strongly together. And if you actually can see the number there, they're a pretty high correlation. It's 0.98. However, you actually have to think about that data. What would those two things have in common? And if the answer is nothing, then you kind of have to question the source of your data. And I think that's especially true if we look at the second graph there. It's per capita consumption of mozzarella cheese versus civil engineering doctorates awarded. Those two things have nothing in common, but for some reason their data points actually kind of coincide, and they have a strong correlation relationship. But again, being a good scientist is also thinking critically. And so in psychology, we kind of have to question the information and always be a little critical about that and make sure we're not being tricked into believing something. And so the guy that made these, if you Google spurious correlations, he's got a ton of other ones that are kind of funny. There's like something about Nicolas Cage movies and like the murder rate in the United States. Those are correlated. So that's kind of funny. But check it out and just kind of, it's just a reminder, be wary about what the data is that we're looking at. And so I have a question here. Christian asks, can correlation be simplified as predicting a cause and effect relationship? Yes and no. I would say yes, because we are using it to predict that there's a relationship there. But the only part we have to be careful about is we don't know which way the cause and effect is going. So it's more about, it seems like these two things go together and it helps me predict that. But the cause and effect part we have to be careful about, because like with the depression example on the previous slide, I can't necessarily say in which direction that cause and effect is going. Good question. All right. So that is it. Those were all descriptive methods. I'm not manipulating anything. I'm just describing humans or animals as they already are. And so if we move on from that, that takes us into the experimental method. And so I'm sure you guys have done experiments in your science classes. You probably have a good background on this already. So I don't know that I need to spend a ton of time talking about it. But basically, in an experiment, a researcher is going to manipulate a variable to see its effect on another variable. And just like we talked about doing things randomly, like pulling people in from the population and random assignment to groups, is really important to control for other relevant factors. So when I'm conducting an experiment, if I have 20 people participating, I need to assign them randomly either to the control group or to the experimental group, because this helps me account for the fact that people might be different ages, people might have different intelligence levels, different backgrounds, different socioeconomic status. And I can't account for that, right? I can't find 20 identical people. And so to kind of balance that out, if I'm randomly assigning them to the groups that they're in, I can at least hope to mitigate some of those differences based just on the randomness of how they're assigned. Some of the key terms here are the control group. And so these are just kind of basic vocab, but understanding that the control group is the group that doesn't get the manipulation. We measure against them. The independent variable is the thing that I'm changing. And I have a whole experiment on the next slide that I'll talk about so we can actually like apply these terms. The dependent variable is the factor that I measure then in response to the independent variable. And then a big thing that you have to worry about with an experiment, is there any confounding variables that might affect my results? Maybe I'm doing a study outside and one of the days with the control group, the weather was really nice, and the other day it was raining. That would be a confounding variable. It's something I didn't account for in the experiment, but could throw off the results because it was different for the different groups. So we always want to make sure we do the best we can to like not have any sort of confounding variable in an experiment. So here's my experiment on the next slide. The leading producer of specialty chocolate wants to increase their sales. They set up a test program in local malls. Identical chocolate is sold at 2 stores. In one mall, the smell of chocolate is circulated throughout the vents. In the other, normal air is circulated. They recorded sales at each store over a period of 6 months. So if people want to just in the chat take a chance at what is the control group, what is the independent variable, and what is the dependent variable. You can just answer one or all of them, and then we'll kind of talk about it. I'm just going to give you a second to think about those because I want you to get a chance to think about what each of those would be. All right, we've got Jamie answering. Anyone else have some answers for that one or other ones? Do we agree? Do we disagree? Yes, I'm seeing some answers. Good. So for control group, it looks like Reagan is right. People in the area where the air is normal, because nothing's happening to them. They're just going about their everyday normal business at the mall. And so that's the normal air group is the control group. They have not been manipulated in any way. The independent variable, Jamie got that right with the air circulated. So that's what's changing. In one mall, the air is regular. In the other mall, it's like the chocolate scented air. So that is what is being manipulated or changed. And that's what we're measuring the result of. So the result of the chocolate scented air is the dependent variable, which is the sales of the store. And so Christian got that one right. We're then measuring, does the chocolate air have an effect? And so the dependent variable is the stores and their sales. Good. So those are kind of the 3 parts there. I posted on the Facebook group, if you guys are members of the AP Psych Students 5able Facebook group, I posted some practice worksheets with independent variable, dependent variable, all of that. So take a look at those. The best way to just kind of practice these is just to keep doing them over and over until you get them down. So I would just recommend kind of doing a worksheet, seeing what you can do, and getting that information. And then I do want to go back. We had a question from Trinity back about the correlations. Trinity asked, is it more significant for a correlational graph to include different data with close results or similar topics with widespread results? And I would say it doesn't matter. It's just what you're investigating. And so if we get data with close results, then we know that there might be a relationship there. And so we can maybe come up with a hypothesis and an experiment based on that. If we get widespread results, that's okay too, because it's all part of investigating and researching something. And then we just see, oh, well, maybe there's not actually a relationship that exists there. So I don't think that it matters. It just is going to guide your thinking and your research about whatever the topic is that you're investigating. All right. And then we have another question from Kylie. Is there an acronym or something to remember control group, independent variable, and dependent variable? I, off the top of my head, unfortunately, do not have an acronym. But you know what I'll do? I will look around and talk to some other teachers tonight and see if they have any sort of ways to remember that, and check the Facebook group tomorrow. And if I find something, I'll add it to the Facebook chat, and you guys can check it out there. But unfortunately, I don't have any quick little fix for that one. Unless someone else does and they want to put it in the chat, that would be great, because someone had one last week that was really good. So yeah. All right. So that is all I have for kind of new information. The other thing then is I just have 5 multiple choice questions that go over different stuff from the research methods unit. Not all of the things I covered today in the discussion, but I know a lot of you are already in the research methods unit, so we can just kind of take a shot at some of those multiple choice questions. So if you want to, in the poll down there, find where it says question 1. And question 1 asks you, which correlation coefficient best represents a moderate relationship showing less anxiety symptoms in people with higher life satisfaction? So there's a couple keywords in that question that are going to give you hints to the answer. So go into the poll and take a shot at what you think the answer is, and then we'll talk about what the correct answer is and why. Are you guys able to access the poll? I think I made them live. Yeah, it looks like people are answering. We've got 1 answer so far. 2 answers. Good. Keep going. Give you like 10 more seconds to get some answers in. Got 5 answers. Keep going. Keep going. Good. Lots of answers. Last call before I answer. All right, so the correct answer here is A, and let's talk about why. So there's a few keywords, and so on the AP test, what's really going to be good for you to get used to is how you read the questions. I always first cross off like irrelevant information, and then I always underline the keywords. And so one of the keywords here is moderate relationship. And so if you know that the numbers only can go from like 0 to 1, moderate kind of means middle. So we're looking for a kind of middle number here. So I think that automatically eliminates E as our choice because that's not in the middle. That's like as far as you can go. And it probably eliminates B and D as well because those are kind of towards the ends. So that leaves us with A and C as our choices. And how do I get there? 1 is minus and 1 is plus. And so we have to look at what the rest of the question says. Fewer anxiety symptoms. So that number is going down. Less anxiety, number going down. And people who report higher life satisfaction. So that number is going up. So we have 1 number going down and 1 number going up, which means that's a negative correlation or an inverse relationship. And so A then is the answer that we can kind of process of elimination get to because that's the one that has the negative in front of it. All right, does that make sense? Anyone questions about that? Otherwise, I'm going to post the second one and then we can always come back. All right, so the second question is talking about designing a study. Magali and Jean-Gabriel have been asked to design a study investigating happiness across the lifespan. They decide their study will involve going to the mall and asking people of a variety of ages if they are happy or unhappy. What is the most serious flaw of this design? So take a second in the poll and answer that one. So question 2 now. So we're down to question 2. Scroll down to that in your poll. And like I said, I didn't directly maybe address some of these topics tonight, but we'll still talk about them through the questions because they're things that are in the research methods unit. And so if you haven't gotten to the unit yet, that's also okay. We're still just talking about best kind of practices for answering multiple choice. Let's see what we've got here. We've got quite a few answers. Okay. Yeah, the correct answer is D, which is what most of us are putting. And so these kind of questions I dislike because they are tricky because it says most serious flaw. About like what the focus of psychology and what we're talking about in like designing a study or an experiment. And so the answer is D because we haven't operationally defined happiness. And so operational definitions are just basically really thorough ways that we describe what we're measuring because happiness is like this vague term, right? Happiness to me might mean something really different to you. So if I don't have a scale or a specific way to like measure happiness, just asking people if they're happy or unhappy really won't give me very valid results. I could see that some people put answer B, survey data is not as valid as experimental data. That's kind of true because we talked about people could lie on a survey, but we still use surveys and we rely on them if we take a big enough sample size. So that's where it gets tricky, where it's the most serious flaw. Like thinking about which of these things would cause us the biggest problem in our experiment or in our study would be the one that not having a solid definition of what happiness is. And it's okay that people, some people put A, it's okay that people know that they're part of a study, and actually we would say that you typically have to get informed consent and people have to agree. You can't just like experiment or study someone without their permission usually. So that's always good to keep in mind. We did have a question that goes back to correlation. Reagan asked, are correlational studies always between 0 and 1? It's from -1 to 1, but yes, the number will never go higher than 1 or lower than -1. And if you see a number that's outside of that, then there's either some mistake or it's not a correlation study. So if you see that, that's your hint to know that it's not talking about a correlation if the number is bigger than 1. Okay. Third multiple choice question, I've got 5 total. So that, get to it. Sandra strongly believes that attending daycare is detrimental to children's development, so she decides to write her psychology term paper on this topic. She does a literature search and finds several articles supporting her opinion, but she finds the majority indicates that children attending daycare experience healthy development. She writes her paper using the sources that find negative associations with daycare and attendance. This is an example of, so go back into that poll and check out question 3. We've already got a few votes. Good. Good. Everyone seems to be getting this one. The answer for this one is A. It's confirmation bias. It's basically like, as a human, I like things that agree with me, right? And I don't like things that disagree with me. And so sometimes I'm biased in the information that I choose because I like the things that agree with me more. And like we talked about previously, that's where we have to make sure we have a really good scientific attitude in psychology and that we're not being biased in the results and the things that we're looking at. And that's also why when you're looking at data and studies, because if you would have read Sandra's paper right here, you would have been like, oh, geez, that does seem like daycare has a negative effect. But if you don't actually like think about, well, what are Sandra's sources and is she representing both sides of the issue? If you don't critically think about that, you could fall for her confirmation bias and then be completely misinformed about that information. So again, one of the big things here is having a scientific attitude, considering where your information is coming from, and critically thinking about that information. Good, that was a good question. Question 4, what is a limitation that affects the generalizability of research results? So why might I not be able to generalize my research results? Question 4 in the polls. And this one's tricky. I think there's 2 answers we could go for here. Ooh, yeah, we're getting lots of answers in the poll right now. Take another 20 seconds or so. Oh yeah, we've got answers all over the board here. This is a tricky one. That's okay. So the correct answer for this one would be sample size, C. And let's talk about that. So we talked about generalizing, you know, in a case study, we're studying one person individually. And so it's difficult to make like a generalization of the, you know, to the rest of the population. And so with sample size, if our sample size is small, that can actually limit how much we can actually talk about whether our research is valid for the rest of the population. If I'm studying all 16-year-olds in the United States, but in my sample, I only sample 10 kids. That's really going to limit how much I can actually generalize my results, because that's not going to actually give me a really accurate picture and accurate idea of what all teenagers in the United States are like. If I did a bigger sample size and I was able to like survey 100,000 teenagers, then I might be able to generalize my research results more. But the sample size, if it's small, makes it really difficult to generalize, because it's not usually then representative of the whole population. All right, question 5. This is the last question. This one's a little long. An upper-level psychology class is conducting an experiment on racial prejudice that involves having participants rate the likability of faces in a set of photos. However, they tell the participants that the study is about the effects of aging on likability. When participants are finished, they are thanked for their time and leave the experiment. In this example, the class forgot to blank in order to resolve the blank. So this is about the ethics of psychology and research. So think about what ethically you would have to do to research or have people participate. Got a couple of votes. Yeah, we're doing well with this question. So it seems like everyone has got this one. The answer here is B. You always have to debrief. If people are participating in a study, one of the things is that we have to inform them of what's happening and talk about it afterwards. And then to get rid of like the deception involved, so that they can kind of leave. Other ethical concerns would be like people have to agree to participate in a study. You can't hurt people. That seems kind of obvious. But yeah, so there are ethical guidelines that researchers have to abide by, even in psychology or any really field of science. Deception is like lying to them. So basically, like Ronak asked a question about deception, and basically, yeah, it's like you can lie to people when you're doing an experiment, as long as after the experiment's over, you tell them what the lie was. They can't go on like continuing to believe that like lie forever. So the deception part is okay as long as it's debriefed afterwards. Good. Okay. So that is really all I have for new stuff tonight. If anyone has any last minute questions, quick throw them in the live chat. Otherwise, like last time I just talked about, if you are enjoying these live review sessions, we have the Crowdcast. You can like follow on the Crowdcast website, and that way it'll always tell you when the next sessions are. You can follow us on YouTube. I'm making videos of certain review things as well that you can watch. Join the student Facebook page. I'm going to double check on that independent, dependent variable stuff to see if I can come up with a little acronym for you guys. And then as always, register for the live reviews. All of September is still going to be included in that. So you guys are still getting the free sessions, which is great. And then if you're in other AP classes, check out the rest of our 5-able sessions on there for like AP. I think there's AP World and AP Human Geo. There's a lot of other classes on there as well. So take advantage of that while you can. Otherwise, it doesn't look like we have any other questions. It was good to see you all tonight, and hopefully I will see you guys next Tuesday while we tackle statistics and some more FRQ writing. So I will see you then. Thank you guys. Bye.